What is superposition in the context of quantum computing? Superposition allows a qubit to exist in multiple states at the same time, rather than just being 0 or 1 like a classical bit. It's like a coin that's spinning so fast it's both heads and tails at once. When in superposition, a qubit has a probability of being in each state. It's actually in all possible states until measured. With multiple qubits in superposition, the number of possible states grows exponentially. Superposition allows quantum computers to process multiple possibilities at once, enabling them to perform certain calculations much faster than classical computers. When a qubit in superposition is measured, it collapses into a definite state of either 0 or 1. The act of measurement ends the superposition. Think of it like this. Each qubit is like a tiny, super-efficient racetrack for electricity, made from materials that don't slow down the flow. Scientists use microwave pulses like a remote control to put these qubits into superposition, a state where they're both 0 and 1 at once. This superposition allows quantum computers to process numerous possibilities simultaneously. When you measure a qubit, it collapses into a definite state, giving you a specific answer. Many quantum algorithms rely on putting qubits into superposition to explore multiple solutions simultaneously before collapsing to the most probable answer. It's often likened to a spinning coin, both heads and tails until it stops, or a musical chord, multiple notes played simultaneously. In essence, superposition in quantum computing is the ability of qubits to exist in multiple states at once, allowing for parallel processing and exponential computational power for certain types of problems. Superposition is a fundamental principle of quantum mechanics that allows quantum systems to exist in multiple states simultaneously. Let's break this down further using coin analogy. A qubit, like a quantum coin, can be in a superposition of both 0 and 1 states simultaneously. Imagine the quantum coin spinning so fast that it's both heads and tails at the same time. While in superposition, the qubit doesn't have a definite state of 0 or 1, but rather a probability of being either. It's not just that we don't know which state it's in. It's actually in both states at once. In superconducting qubits, tiny circuits made of superconducting materials can carry current without resistance, and their quantum states can be controlled using microwave pulses. Imagine you have a very special type of electric circuit, like a tiny, super-efficient racetrack for electricity. This special circuit is made from materials that allow electricity to flow without any resistance. Think of it like a racetrack where cars can zoom around without ever slowing down because there are no bumps or friction. In the real world, this is called a superconductor. To control this circuit, scientists use something like a remote control that sends out invisible waves, similar to how your TV remote works. These waves are called microwave pulses. The circuit can be in different states, kind of like how a light switch can be on or off. But here's the cool part. In the quantum world, this circuit can be in a state that's both on and off at the same time until you check it. This is superposition. When scientists send these microwave pulses to the circuit, they can change its state. They can make it be in superposition, both on and off, or make it switch between states in very precise ways. Why it's important. This ability to be in multiple states at once and to switch states precisely is what makes quantum computers so powerful. They can perform many calculations at the same time, which can solve certain problems much faster than regular computers.